Okay, we're going to be looking at the test that we took in the end of this half term. When you're going through this test, I strongly recommend watching every single tutorial for each question and correcting your question, making sure the presentation of your solutions is concise and clear and good for the reader. So let's begin. This question is about some data. We're asked to find the range of the data. In most of these questions, at some point we're going to have to arrange them in order, so we should do that to start with, the smallest value being £1.90. When we're looking for the range, we're going to be looking for the highest, subtract the lowest. Okay, so let's put £1.90 here. The next value being £2.50. Then £2.80. Now when people did this question, lots of people missed out one of the values from the list above. A good way to not miss out values is to cross the ones that you've written down. So if we cross the ones we've written down, we could then cross out 3 and put 3 there. The next value would be £3.20, we cross it out, we put it here. Then £3.60, then £3.80, and then £4.25. So the most common error on this question was to miss one of the numbers, thereby not getting the correct median. So finding the range, £4.25, subtract £1.90 is £2.35. The median, well, we cross out from either end, and we find that there are two values in the middle, 3 and £3.20. Halfway between 3 and £3.20 is £3.10. Okay. Next question, work out the value of 2t minus 5. So, we should really rewrite the question. Then we're going to replace t by the value we're given, which is 11. So it's 2 times 11 minus 5. Notice how in each line I just change one thing. The line after this, we're going to change 2 times 11 to 22. And after that, we're going to change 22 minus 5 to be 14. I could put equal signs here, here, and here, because each line is equal to the previous line. Okay, what I didn't like about people doing this question is they worked out what 2 times 11 was, and they said that was equal to 22. Then after they wrote equals 22, they wrote subtract 5, something a bit like this. 2 times 11 equals 22 minus 5, which equals, what did I say? 14. I didn't mean 14. I meant 22 minus 5 is 17. Sorry about that. So they would say 22 minus 5 is 17. Okay, you can see this isn't right because this says that 2 times 11 is the same as 17, which isn't correct. So you shouldn't write like this. You should work down the page, not across the page. Okay, early in the morning. Right. Carrying on, we're going to follow the same method for this one. So if you did question 3, but you did it like you did question 2, then perhaps is a good time to pause the video and rewrite your solution now and check that your solution matches mine. Okay, so I'm going to rewrite the question. Just underneath that, I'm going to change R for 5 and S for 7. Okay, so now we can replace 5 squared by 25. Then we're going to replace 2 times 7 by 14. And finally get an answer of 11. I believe this time it's correct. So the reason why we do it like this, or one thing to note is I've changed 5 squared first because I did the indices. Then I did the multiplication, and then finally I did the subtraction. You can put equal signs here, here, and here because each line is equal to the previous one. And write the final answer as being 11. Okay, next. So most people did this question correctly, almost everyone in fact, and if you didn't, then do check whether you understood what it means to be a term. So to be a term, you must have a sign, you must have a number, and you may have a letter. So I've circled the term 8, the term plus 4x, the term plus 3x, and the term minus 5. Now I may write these in a different order. I may write the x terms first, and then the unit terms Second, we can add the x terms. 4x plus 3x is 7x, and 8 minus 5 is plus 3. So that should be your final answer. Okay, looking at this question, most people just didn't understand what Q was. Q is the number of questions. Okay, so that equation says C is equal to 10 plus 2.5 times by Q. 2.5 times by Q, where Q is the number of questions. At the end here, you're given that there are 20 questions. So you're going to use 10 plus 2.5 times 20, because 20 is the number of questions and Q is the number of questions. It's a substitution question. I was very confused by some people's solutions. I didn't understand what they were doing. So we can rewrite the question here. I've written a time sign now. Then we're going to do 10 plus 2.5 times by 20, because 20 is the number of questions. Then we're going to follow order of operations. So we're going to do 2.5 times 20, which is 50, and then 10 plus the 50 is 60. So you should have got £60 for that question. Do notice as well how I've kept the equal signs in line. From line to line, nothing changes except for one thing. Okay, so let's look at the next question. Here, again, people were confused by what C was. C was the temperature in degrees Celsius. We're given the temperature in degrees Celsius is 50 degrees Celsius. So all we do is we substitute C for 50 degrees C. So we're substituting C for 50. That does not mean, and this was the mistake that most people made, was they thought that 9C meant 9 degrees C. That's not true. It means 9 times C. It's an equation. Okay, so F is equal to 9 times C over 5 plus 32. So we're just going to be replacing C by 50. Okay, and then once we've replaced C by 50, we can start going through order of operations. Let's do that multiplication on the top line first. So 9 times 50 is 450 over 5 plus 32. You should probably pause the video and complete this. Continuing, we get 90 plus 32, which is equal to 122. So again, notice how the equal signs are all in line. You could write F here and F here because the left-hand side doesn't really change. Final answer, 122 degrees Fahrenheit. Okay, next. So, tick all those that are correct. So, we are looking for fractions that are equal to 3/8. 9 and 14 have no common factors. 30 and 80, common factor of 10, divide through top and bottom by 10, you get 3 over 8, so that's the same. 37 and 87, well, they're both prime, so they have no common factors. 21 and 56 do have a common factor of 7. 7s into 21 go 3 times, 7s into 56 go 8 times, so this is also the same. Okay, two methods for question 8. The first one was to find a common denominator and work out their equivalent fractions. The common denominator in part A looks like it will be 40ths. So, 2/5, or we've times the denominator by 8 to get from 5 to 40, so we're going to times the numerator by 8 also to get 16 over 40. We've times 8 by 5 to get to 40, so we're going to times 3 by 5 also to get to 15. So 16/40 is bigger than 15/40, so this is correct. Part B. We're not going to do anything to the 16ths, we're going to keep them exactly the same. We're just going to times the denominator of 3/8 by 2, and also times the numerator by 2 to get 6/16. And indeed 6/16 is bigger than 5/16, so this is also true. The other method that some people went down was to turn their fractions into decimals, which was also a good move. So 5s into 2 go 0.4 times, using bus stop method. 8s into 3, well, 8s don't go into 3, 8s into 30 go 3 times, remainder 6, 7, remainder 4, so it's 0.375. So indeed you can see that 2/5 is bigger than 3/8. If we do 5/16, well, 16s into 5, 16s don't go into 5, 16s go into 50, 3 times remainder 2, go into 20, 1 time remainder 4, go into 40, 2 times remainder 5, go into 8, go into 80, 5 times. So, let's go back. You can see that 5/16 is bigger than, or is smaller than 3/8 rather. Okay, I think one person did this wrong because they didn't divide by the denominator, they divided by the numerator. So let's move on. Okay, so the question's slightly different in your test, the question also said you can write your answer as a top-heavy fraction. So I would say in all questions, just don't bother with mixed numbers. I think they're a waste of your time, and I generally have told you that we hate mixed numbers, so don't bother. You probably wouldn't have made a mistake with mixed numbers in question 9, but if you did use mixed numbers in question 10, I guarantee you got it wrong. So let's look at this. 4 and 7/9 plus 2 and 13/18. So we're going to use our cleaver writing style. The next line here, where we're going to change 4 and 7/9 to be 4 times 9 is 36 plus 7 is 43/9. 2 times 18 plus 13 is 49/18. We can't add these because they're different types of fractions. Lowest common multiple of 9 and 18 is 18. So 43/9 becomes 86/18. Add the 49/18. At this stage we can just add them. So we have 86/18 and 49/18, giving us 135/18. Now, if you stopped here, you should have lost a mark because it asked for its simplest form. There is a common factor of 9 between numerator and denominator. So 9's going to 135 15 times. Go back. And go into 18 twice. So it's 15/2 or 7.5. Or 7.5. So that was the answer. Let's look at the next one. So as I said, we hate mixed numbers, so we're going to go straight into top-heavy. 6 and 1/4 minus 1 and 11/12 is going to be 25/4 minus 23/12. Lowest common multiple of 4 and 12. 12 is 12, so this becomes 75/12 minus 23/12. 75/12 minus 23/12 is 52/12. You shouldn't stop here because it asks for its simplest form. Common factor is 4, giving you 13/3. That was fine as an answer because your test was a later draft of this test and you're allowed to write it as a top-heavy. So if you got this wrong using mixed numbers, this is probably why. So we have 6 and 1/4 minus 1 and 11/12. You would have then said it's 6 minus 1 is 5, and then we have 1/4 minus 11/12. So we have 5 and 8/12 minus 11/12, and at this stage what you would have done is you would have probably said that 8/12 minus 11/12 is 3/12. That's not correct. 8/12 minus 11/12 is minus 3/12. So what we have here is we have 5 and minus 3/12. We could replace the and by an add sign, so it's really 5 plus minus 3/12. So this would give you 4 and 9/12. So if you got that wrong, it's because you were using mixed numbers, and we don't like mixed numbers, we prefer top-heavy. So can you always use top-heavy fractions in future, please? Okay, here we have a question about a frequency table. Now, if you made an error in this question, it's probably because you didn't really understand the table and the word frequency. The word frequency here means how many times something happens, something occurs. Okay, so this question is a table about the number of tracks on a CD. So we have that we found 1 CD with 11 tracks, 3 CDs with 12 tracks, no CDs with 13 tracks, 2 CDs with 14 tracks, and 4 CDs with 15 tracks. Again, I'll repeat that. If you made an error with this question, it's because you probably didn't understand how the table worked. So if we write down the mode now becomes easy when we understand this table because we know there are 4 CDs with 15 tracks, and that was the most common occurrence. So a CD with 15 tracks occurred 4 times, so that is the mode. The mean, I saw some people do this well. One way to do this would be just to list the data in its original form. So we could say there was one CD with 11 tracks, 3 CDs with 12 tracks, no CDs with 13 tracks, 2 CDs with 14, and 4 CDs with 15. So that would be what the data might look like in its original form as a list. To find the mean, we're going to need to work out the total of this. So we add them all up, and we find that when we add them up, we get 135. And if we look at how many data bits we've got 10 data bits, so we divide it by 10. If you made a mistake in this, it's possibly because you divided by 5, because you saw there are 5 rows in this table, but that's not how many CDs there were 10 CDs. What I also saw, which was nice, was some people using the extra column and multiplying the number of times something occurred by the number itself. So 1 times 11 is 11, 3 times 12 is 36. Well, in this column we're really looking at the total number of tracks. So if we have one CD of 11 tracks, that's 11 tracks in total. 3 CDs of 12 tracks, that's 36 tracks in total. 2 CDs of 14 tracks, that's 28 tracks. And 4 CDs of 15 tracks, that's 60 tracks. Adding this column up gives you 135. And we need to divide by the number of CDs. Well, that's the frequency column. That's how many occurrences we have. And we have 10 CDs that we looked at. So that's what we need to divide by, not 5, because there are 5 rows. Okay, write down the range. Well, the highest number of tracks was 15 minus the lowest number of tracks was 11, so the mode is 4. Okay, sample space diagram. Everyone, I think, got the sample space diagram correct. Look like this. And if we look at the questions, what is the probability of getting a head and a 4? Well, that happens just there, and it's 1 time out of a possible 12. Tail and prime. So if you got this wrong, it's because you didn't know your prime numbers. Prime numbers in this table are 2, 3, and 5. So tail and a prime, so it's that one, and that one, giving you 3 possibilities out of a total 12 from the sample space diagram. A head and a factor of 12. Again, if you got this wrong, it's because you didn't know your factors of 12. Factors of 12 are 1, 2, 3, 4, and 6. So that's 5 occurrences from a total of 12. Tail and a number bigger than or equal to 4. Now, hopefully everyone knows what bigger than or equal to 4 is. And if we highlight those options, we have 4, 5, and 6. So there are 3 possibilities out of 12. You may have simplified these fractions, but you weren't asked to, so there was no need. If we carry on. Okay, so we've got some multiplication of fractions, and from earlier we know that we hate mixed numbers. We shouldn't really use mixed numbers when we're multiplying fractions anyway. It's just not possible. So let's turn them to top heavy. We get 13 fifths for 2 and 3 fifths because 2 wholes is 10 fifths plus 3 fifths is 13 fifths times 10 over 11. 13 times, we're going to times the numerators and the denominators together. If you're not sure why this is true, maybe go back to one of the fractions videos and review this topic. So 13 times 10 over 5 times 11. We can at this stage cancel common factors. Common factor between numerator and denominator here is 5. 5's go into 10 twice and 5's go into 5 once. And now we can say that it's 13 times 2, which is 26, over 11 times 1, which is 11. You could leave your answer there. So, division of fractions. We're going to kiss and then flip. We will, underneath, write 12 times 13 because we're times the numerators, and 65 times 2 times the denominators. Most people correctly identify there was a common factor between 2 and 12. 2's going to 2 once, 2's going to 12 6 times, but didn't identify that 13 and 65 have a common factor of 13. 13 is going to 13 once, and 13 is going to 65 5 times. So now we have 6 times 1, which is 6, over 5 times 1, which is 5. If you lost a mark here, it's probably because you wrote down that the answer was 78 over 65. If you've written 78 over 65, you can check, but there is a common factor of 13 between numerator and denominator. And I believe the question asks for its simplest form. Okay, so let's move on. A simple spinner with a probability table. If we add up the probabilities we've got so far, they add up to 0.75, leaving the remaining probability for the blue section as a quarter or 0.25. You didn't need to write it as a fraction or a decimal or a percentage. A decimal is fine. Work out the probability that the wheel will stop at either yellow or red. So we just add the probabilities for yellow and red, giving you 0.35 plus 0.1, which is 0.45. Okay, that was fairly straightforward. 1 mark, 1 mark. You didn't really need to show any working. Moving on. So complete this table. A couple of people made some mistakes on this. Firstly, it does ask for simplest form. So if where we've got 0.4, you've written 4/10, that can be simplified to 2/5. I believe the question on your test was 5/8. As I said, this is an early draft of the test. So the method was done well by most, but maybe not accurately enough. So 8s into 5 don't go, 8s into 50 go 6 times, remainder 2, 8s into 20 go 2 times, remainder 4, 8s into 40 go 5 times. So you've got 0.625 as the decimal equivalent of 5/8. Okay, question 16 was a pie chart question. I think about half of us got this right. I guess the key information here, and this is what I showed you when we were learning this, is it's good to find out what angle one student represents. We know that 120 students represents the whole circle, the whole pie chart, so 360 degrees. They've given you a nice number of 120, so this means that one student, if you do 360 divided by 120, you get 3 degrees. So each student represents 3 degrees. When you know this, the question becomes very straightforward. If we look at the number of people who chose plain flavoured crisps, that was 15 people. Each person represents 3 degrees. 15 times 3 is 45. So we're using a multiplier here. We're timesing everything by the same amount. 40 people would represent 120 degrees. 55 people, if you times by 3, you get 165 degrees. And 10 people, if you times by 3, you get 30 degrees. Some people did some really strange stuff here. Have a look back at your answer and just ask yourself, does it make sense? Okay. A nice check you can do is to add the angles and check they add up to 360. Okay, we've got 2 more questions left, I believe. So this question was fairly tough. I'm going to show you the method I would use to solve this question. So the key information here is that her mean is the same as her range and that the median score is the one that is missing. So we can write them in order. It's useful to write these pieces of data in order, and we'll include the missing piece of data as well in this. 10, 12, missing piece of data, 21, 28. So we know that the mean is equal to the range. We can work out the range because the range won't change if we put in the median. 28 minus 10 is the range, which is 18. So we know that the mean is 18. What is the mean? Well, the mean is going to be the sum of all of these. I'm going to call the unknown value there x. If we add them all up, we get 10 plus 12 plus x plus 21 plus 28 divided by the number of data bits, which is 5. Okay, so let's do some simplification. We can add the like terms in the numerator there, the like terms being all the numbers, and if you add the numbers, you get 71 plus x over 5. And I've written there that 71 plus x is equal to 18, because we know that the mean is 18. So 71 plus x is 18. So if 71 plus x divided by 5 is 18. So if 71 plus x divided by 5 is 18, what does 71 plus x have to be? Well, we could times both sides by 5, and 71 plus x, therefore, would have to be 90. This means that x must be 19. So check the method there, and you can check it works in the original equation. So if we look at this first equation here, if we add the numerator, we get 90. 90 divided by 5 is 18. So this works. Okay? So the answer should be 19. Some people wrote 16.5 for this, and I'm not quite sure why they wrote 16.5, but this is the method I would use to solve this question. Let's look at the final question now. So, we're given that we want a mean of 4, a median of 4, and a range of 5 for 4 numbers, hint being that they don't have to be whole numbers. I think we'll use that hint later. So when I was teaching you how to do questions like this, I just said find something that fits some of the criteria. The obvious thing that fits some of the criteria is just writing a list of 4s here. Because it's got a median of 4, and it's got a mean of 4. If you add them all up, you get a total of 16, so it works. So this would be fine for 2 marks. We can then start to amend our solution here to make a range of 5. To make a range of 5, we just had to add a bit to the highest value and take a bit from the lowest value. If we add 2.5 to the highest value and subtract 2.5 from the lowest value, we'll get the correct solution, or a correct solution. So this would be one correct solution. The range is now 5, so we're happy. You could have also changed the 2 middle numbers. Some people wrote things like 3.9 and 4.1, or 3 and 6. 3 and 5. But this is probably the easiest solution. Okay, thank you for watching. Make sure you've made all the corrections to your solutions, and hopefully, having gone through these, you can see where you could have done better in the future.